Let us now look at the consumer's budget, budget set, and budget line. Suppose a consumer has a budget of 60 rupees, which he wants to spend on apples and oranges. Let us assume that one apple costs 2 rupees, and one orange costs 1 rupee. Now, look at the table. With a budget of 60 rupees, the consumer can buy different combinations of apples and oranges. He can buy 0 apples and 60 oranges. Or, he can buy 10 apples and 40 oranges. Or, he can buy 20 apples and 20 oranges. Or, he can buy 30 apples and 0 oranges. These different combinations of apples and oranges that the consumer can purchase with his given budget form the consumer's budget set. Now, let us plot these combinations on a graph. Apples are shown on the x-axis, and oranges are shown on the y-axis. When we join these points, we get a straight line called the budget line. The equation of the budget line is P1x1 plus P2x2 is equal to y. Here, P1 is the price of an apple, and x1 is the number of apples. P2 is the price of an orange, and x2 is the number of oranges. And y represents the consumer's budget. Therefore, the budget line represents different combinations of apples and oranges on which the consumer spends his entire budget. Let us now understand feasible and non-feasible combinations. Any combination that lies on the budget line or below the budget line towards the origin can be purchased within the consumer's budget. These combinations form the feasible region. On the other hand, any combination that lies above the budget line cannot be purchased with the consumer's available budget. These combinations form the non-feasible region. Now, let us look at the slope of the budget line, also called the price line. The slope of the budget line depends on the prices of the two goods. In our example, apples are shown on the x-axis and oranges are shown on the y-axis. The slope of the budget line is equal to the negative ratio of the price of apples to the price of oranges. That is, minus px divided by py. It can also be expressed as delta y divided by delta x. Since the budget line slopes downward, its slope is negative. Therefore, the slope of the budget line is equal to minus px divided by py. Let us now look at how changes in the consumer's budget and the prices of goods affect the budget line. First, let us consider a change in the consumer's budget. When the consumer's budget increases, the budget line shifts away from the origin. This means that the consumer can now purchase more apples and oranges. When the consumer's budget decreases, the budget line shifts towards the origin. This means that the consumer can purchase fewer apples and oranges. Now, let us consider a change in the price of apples. If the price of apples decreases, while the price of oranges and the consumer's budget remain unchanged, the budget line rotates to the right. This is because the consumer can now buy more apples with the same budget, while the maximum quantity of oranges remains unchanged. On the other hand, if the price of apples increases, the budget line rotates to the left. The consumer can now buy fewer apples, while the maximum quantity of oranges remains unchanged. Similarly, a change in the price of oranges will cause the budget line to rotate along the y-axis. Let us now look at consumer equilibrium under indifference curve analysis. Equilibrium is achieved when a point on the indifference curve matches the consumer's budget. At the equilibrium point, the indifference curve is tangent to the budget line. This means that the slope of the indifference curve is equal to the slope of the budget line. Therefore, MRSXY is equal to minus PX divided by PY, which is equal to delta Y divided by delta X. In our example, X represents apples and Y represents oranges. Now, let us look at the assumptions of indifference curve analysis. First, the money income of the consumer remains constant. Second, the two goods are substitutes for each other. Third, The consumer's scale of preference for the two goods does not change. Fourth, the consumer is driven by monotonic preferences. This means that the consumer prefers to have more of the product. And fifth, the consumer is rational and tries to achieve the highest possible level of satisfaction within the given budget. But a noteworthy point is, even indifference curve analysis depends on satisfaction associated with cardinal numbers such as 15 apples and 30 oranges, or 20 apples and 20 oranges, etc.